Hello friends, a very warm welcome to the discussion of another topic in mathematics for CSAT examination. Today's topic is time and work. Now usually you find one or two questions from this topic, and apart from that, whatever the concepts that you learn in time and work will also be applicable in the questions based on the topic pipes and cisterns. So let us have a look at the very basics and then gradually move on to the questions of various difficulty levels. Alright, so this is how the questions seem most of the times. If A alone and B alone can complete a work in X days and Y days respectively, that means A can complete a work in, let us say, X days, and B can complete the same work, let us say, in Y days, then in that case, if you need to find out that if both A and B work together, then in how many days the work will get completed. Now, very first thing that you must notice is that A can complete this work working alone in X days, and B alone can complete this work in Y days. So obviously when both are combined, the number of days taken by both A and B to complete the work would be lesser than X and lesser than Y. So let us say that together A and B take Z days to complete the work. Now here kindly understand that X is going to be greater than Z and Y is also going to be greater than Z. Obviously, if two people are working on a particular job, then the time taken would be much lesser than their individual capacity. Now, here we have an expression that is xy by x plus y. I'm going to tell you three ways in which we can solve such questions. This is the very first one. So let us take an example here. Let us say that A can complete a work in 20 days and B can complete the same work working alone in 30 days. Now if A and B they work together, then the time taken by them to complete the work will be xy by x plus y. Now substituting these values, let us say this is x and this is y. So it will become 20 into 30 by 20 plus 30. So now first thing, in such kind of a method, kindly do not multiply the numbers which are given to you in the numerator. The reason, if you just resolve the mathematical expression which is given to you in the denominator, that is 20 plus 30, it works out to be 50. Now you can always balance out these numbers in the numerators and the denominators. So zeros will cancel anyhow, and this 5 will cancel, this 20 goes by 4. So finally we are left with 4 and 3. So hence it becomes easy. Now we know that if A and B together work, then they would be able to complete this job in just 12 days. Now we should also know this, that if A can complete the whole work in X days, then the amount of work that A will do in one day or complete in one day is going to be 1 by X. Is going to be 1 by X. So let us say what will be 2 days work of A? It will be 2 by X. What will be 10 days work of A? It will be 10 by X, and likewise. So here if A can complete a work in 20 days, then A's 1 day work is going to be 1 by 20. A's 5 day work is going to be 5 by 20. A's 20 days work is going to be 20 by 20, that is 1 full work. Now, similarly for B, 1 day work for B is going to be 1 by 30 and so on. Alright, as we can see here, if B can complete a work in Y days, then 1 day work of B, or the amount of work which is completed by B in 1 day, will be 1 by Y. 2 days, 2 by Y. So number of days divided by those number of days in which B can complete the work working alone, that is Y days. Now if A and B both have to complete this work together, so obviously it is going to be 1 by X plus 1 by Y, that is A is 1 day work plus B is 1 day work. Now 1 by x plus 1 by y is, as you know, x plus y by xy. Now this is 1 day work of A and B. Now, as you see, the total number of days in which an individual can complete the work working alone, in this expression 1 by x, it is x, the denominator. So hence, if you take reciprocal of this, it works out to be xy by x plus y, the very expression that we are looking at right now. Alright, so let us solve a question and understand this in a better way. If A alone and B alone can complete a work in 10 days and 15 days respectively. So A can complete a work in 10 days. B can complete the same work in 15 days. Then together, they will complete the same work in how many days? Now, you know the formula already. It is xy by x plus y. So this becomes 10 into 15 divided by 10 plus 15. So how do you write it? 10 into 15 by 10 plus 15 becomes 25. Now, as it is, you saw that I have not multiplied this 10 with 15 also in the numerator. Why? Let us cut this. 5 3s are 15, 5 5s are 25, 5 2s are, so 2 into 3 is what we are left with, which works out to be 6 days. So, in such a case, given that A can complete a work in 10 days and B alone can complete the same work in 15 days, and now if A and B join hands and work together, then the work will get completed in mere 6 days. Now there is another method which is called percentage method here. Now we know that 1 day work of A is 1 by 10, as you can see here. That means in 1 day, A completes 10% of the work. That is his efficiency. Now similarly, 1 day work of B is 1 by 15, which means that B can complete 20 by 3% of the work in a single day. Now what is this? How did we get 20 by 3 here? Well, nothing. 1 by 15 into 100. So 5 3s are and 5 20s are. That's it. So now if you want to combine the working efficiencies of A and B together, as they're going to work together, then 100% work will get divided by the total working efficiency per day of A and of B together. So this 10 plus 20 by 3 works out to be, let us say, 50 by 3. 3 goes up, becomes 3 by 50. So still we get 6 days. Now the third method is the LCM method, and I am going to advocate for this because this is the fastest as well as the most logical method, although you can definitely adopt the other two methods. Now in LCM method, as the name suggests, you take the least common multiple of the number of days in which A can complete a work and B can complete a work. See, A can complete a work in 10 days. B can complete the same work in 15 days. Now here, it is better that you remember or memorize the LCMs of few numbers together, or else you should be quite fast at finding out the LCMs. I'll tell you a method to find out the LCM of 2 or 3 numbers, which will be a faster approach. Well, we know out of 10 and 15, the higher number or the greater number is 15. Now what you have to do is, you just have to recite the table of 15, and as you recite the table of 15 and move on from one multiple to the other multiple to the third multiple, you have to find out that least multiple of 15, which is also divisible by 10. So let us recite the table of 15. 15 into 1, 15. Is it divisible by 10? No. 15 into 2, 30. Is it divisible by 10? Yes. So you have found your LCM. So LCM here happens to be 30. Now as you see, 10 into 3 is 30 and 15 into 2 is 30. So what you do is, it simply means that A's efficiency is that it completes 3 units in one day, and B's efficiency is that it completes 2 units of work in one day. So 3 plus 2 will be 5 units of work. It gets completed in one day by both A and B. So only thing that you now have to do is that you have to divide this 30 by 5. That's all that you need to do. So your answer here is nothing but 30 by 5, which is 6 days. So what did we do here? Well, if A can complete a work in A days, B can complete the same work in small b days, and here we find out the LCM of A and B, and we know that A into M, let us say, gives us this LCM, B into N gives us this LCM. Here, this would be the combined efficiency of A and B. So our answer here, or let us say the number of days in which A and B both can complete this work, is given by LCM of AB divided by M plus N, sum of these multipliers. Let us solve some more questions, and then we will be able to find out how effectively we can use this method. Now, if A alone and B alone can complete a work in 16 and 24 days, the 16 is for A and 24 is the number of days in which B completes the work, then how many days will they take to complete the work working together? Now, if you remember, we discussed a method that is xy by x plus y. X here is 16, y here is 24. Substituting these values in this formula, this is what we get. 16 into 24 by 16 plus 24. So, as I told you, let us not multiply 16 and 24. Let us simply first add 16 and 24, we get a 40. Now, you can balance things out. As you see, 8 into 2, 8 into 5. So, you have a 2 here, you have a 5 here. So that you get 48 by 5, which now can be expressed in terms of mixed fractions as 9 3 by 5 days. Now, let us try and solve this question with the help of LCM method. See, if you have only two persons, A and B, working alone and then they have to work together, then in how many days do they complete the work kind of question, then this will definitely work fine. But so will this LCM method for all the questions actually. So A can complete a work in 16 days, B can complete the same work in 24 days. Now, which is the higher value out of 16 and 24? It is 24. Let us recite the table of 24. 24 into 1, 24. Is it divisible by 16? No. 24 into 2, 48. Divisible by 16? Yes. 16 into 3 is 48. So LCM here works out to be 48. How? Well, 16 into 3, the multipliers we will write here, which are nothing, but they tell you about 1 day efficiency of A and B individually, or how many units of work is done by A in a day and by B in a day. So 3 plus 2 is what we will do here, which is nothing but 5. 48 we have to divide by 5. So our answer here will be 48 by 5, which is 9 3 by 5 days. Definitely a faster approach and with lesser calculations. Now let us have a look at another variety of questions. Now in such kind of questions, there are two persons A and B. Initially, one person will complete a particular portion of the work and then he will stop. And the remaining portion of work will be completed by the second person. Now in such kind of a scenario, what should be our approach while solving these questions? Now A and B working together can complete a work in 6 days. If A alone can complete the work in 10 days, then in how many days can B alone complete the same work? Now in such a case, again you can use that xy by x plus y. Only thing is that this time your x is A and B together. Or let us say A here in this case can complete the work in X days. A and B can complete this work together in Y days. Then B alone can complete this work in XY by X minus Y days. Now let us apply this. X days, so A can complete a work in 10 days, so this is 10. A and B together can complete this work in 6 days, so this is 6. Divided by 10 minus 6. So once again, this is 10 into 6 by 4 goes by 2. This is 3. This is 5. So 5 into 3 is what we are left with here. Our answer here should be 15 days. Now let us take up the LCM method. Now it is given to us that A and B can complete this work working together in 6 days. Now A alone can complete this work in 10 days. Now we will have to find out the LCM between 6 and 10. The process remains the same. Which is the higher value between 6 and 10? 10 is the greater number. So let us recite the table of 10. Is 10 divisible by 6? No. 10 into 2, 20 divisible by 6? No. 10 into 3, 30 divisible by 6? Yes. So we found out the LCM as 30. This is the LCM of 6 and 10. And how do we get it? Well, 6 into 5 and 10 into 3. Now what you have to find out is the working efficiency of B, so that you can find out that in how many days can B alone complete the work. See, the combined work done by A and B in one day is 5 units, out of which A does 3 units of work. So hence, B does how much? B in a day does 2 units of work. And the total units are how many? 30. So B alone can complete this work in, again the same thing, 30 divided by 2. Only thing is here, we reduced. We used minus symbol here. We subtracted 3 from 5. Reason? Well, this is given to us as combined, out of which A is here. So to find out B, we have to subtract A's work done, that is 3 units, out of combined work done of A and B, that is 5 units. So 30 by 2, very easily you get 15 days. Now, to sum it up, if A and B alone can do a work in X and Y days, then together they will complete in how many days? Well, then you add here. When A and B combined is given to you and one person's efficiency, it is mentioned to you that one person completes the work in so many days. And you have to find out in how many days can the second person complete the work. Well, from the combined units of work done by A and B, you reduce A, so leftover is the work done by B in a single day. That's it. Alright, let's have a look at another question. A and B together can complete a work in 18 days. Okay, so A and B together is given to you. If A alone can complete that work in 30 days, then in how many days can B alone complete the same work? So what do you have here? You have 30 into 18 by 30 minus 18. Alright, so 30 into 18, as we did xy by x minus y this time. So this is by 12. So 6 2s are, 6 3s are, and this is 15. So 15 into 3 is 45 days. So B alone can complete the same work in 45 days. Now let us make use of LCM method. So let's have a look here. A and B together can complete the work in 18 days, out of which A alone can complete the work in 30 days. 30 is a greater number. So 30 not divisible by 18 into 2, 60 not divisible by 18 into 3, 90, yes, is divisible by 18. So 18 into 5, this is into 3, 5 minus 3 is 2, 90 when divided by 2 shall give us 45 days as the working efficiency of B. So B alone can complete this work in 45 days. See, currently this method is fine if at all there are 2 persons working together. But when the question is about 3 persons working together, then it may take a little longer time with this method. So LCM method is what we have to adopt finally. Now here we go. Now we have three persons working on a particular work. So if each person out of A, B and C can complete a work in X, Y and Z days respectively, then in how many days can all the three persons working together can complete the same work? So let us use LCM method here. Numbers are not given, values are not given for X, Y and Z. So a general expression can be found out here. So A, let us say, does A units of work in X days. B does B units of work in Y days. C does C units of work in Z days. So find out the LCM of X, Y and Z. And then finally, as we had discussed, LCM of X, Y, Z divided by A plus B plus C. Now what does this mean? A simple way of explaining this would be with the help of an example. Now look at this question. If A, B and C working alone can complete a work in 10, 15 and 20 days respectively, then in how many days can they complete the same work working together? Alright, so A can complete this work in 10 days, B can complete this work in 15 days and C can complete this work in 20 days. Find out the LCM. Highest number, greatest number is 20. Table of 20. 20 is not divisible by 15. 20 into 2, 40 is not divisible by 15. 20 into 3, 60 is divisible by 15. We are not bothered about 10 here because anyhow 20 is divisible by 10. So any number which is divisible by 20 will be divisible by 10 also. So we should only be bothered about 15 and 20. We will find their LCM, which works out to be 60 here. Now, what are the multipliers? So the multipliers here are nothing but they represent the units of work done individually by each person in a day. Alright. So 10 into 6, 15 into 4 is 60 and then 20 into 3 is 60. So finally what do you get? 6 plus 4 plus 3, that is 13. What do? You have to divide 60 by 13. So A, B and C together will complete this work in 60 by 13 days. That is 13 4s are 52, 8 by 13 days. That should be the answer here. So simple as that. So previously we were finding out LCM of two numbers. Now we are finding out LCM of three numbers. Alright, let's do another question of this sort. If A, B and C working alone can complete a work in 10, 15 and 12 days respectively, then in how many days can they complete the same work working together? So A can complete the work in 10, B can complete the work in 15 days and C can complete the work in 12 days. So together they will be able to complete the work in 60 days. I mean, if you just recite the table of 15, the highest number, 60 is the number which is divisible by 10 as well as 12. So 10 into 6 is 60, 15 into 4 is 60, 12 into 5 is 60. So 1 day work of A, B and C combined together will be 6 plus 4 plus 5, that is 15 units. Total number of units is the LCM, that is 60. 1 day number of units completed by A, B and C together in 1 day is 15. So just divide 60 by 15. So 60 by 15 we get 4. So if A, B and C for these instructions they work together, they will be able to complete the work in 4 days. That's it. If A and B together can complete a work in 20 days, now mind you, this is not one person. A and B, two persons together can complete a work in 20 days. Now B and C together can complete the same work in 24 days. And C and A together can complete the same work in 30 days. Then in how many days can A, B and C complete the same work working together? Well, here also you can make use of LCM method. It will be very effective. See, A and B together can complete a work in 20 days. This is given. B and C in 24 days. So B and C 24 days and C and A 30 days. Finding out the LCM, 20, 24, 30. 30 is the highest number. 30 is not divisible by 24 or 20. 60 is not divisible by 24. 90 is not divisible by 24. But 120 is divisible by 24 as well as 20. So the LCM here works out to be 120. So we have 120 units of work. So 20 into 6 is 120, 24 into 5 is 120, 30 into 4 is 120. So the total works out to be 6 plus 5 plus 4, that is 15. But what is this total? Total number of units of 2 days work of A, B and C. Why? See, A is mentioned twice, B is mentioned twice, C is mentioned twice. So 2 days work of A, B and C is 15. In 2 days, A, B and C, they complete 15 units. So in 1 day, A, B and C will complete how much? Well, 15 by 2. Now what you have to do? You have to divide 120 by 15 by 2. That's all that you need to do. So 120 by 15 by 2, that is 120 into 2 by 15. 15 into 8 is 120 and 8 into 2 is 16. So A, B and C together will be able to complete this work in 16 days. So just notice this, that A, B and C, each person's working ability or efficiency has been included twice here. This is A1, let us say this is A2, kind of a thing, alright? So 2 days efficiency is 15 units, so 1 day will be 7.5 units. 7.5 units is how much? 15 by 2. Now look at this one. A can complete a project in 15 days. He started working, after 5 days he left. The remaining part of the project was completed by B in 20 days. In how many days can B alone complete the same work? Now I will use a timeline here. Now why I call it a timeline? This is the starting date and this is the ending date, let us say. Now it is given that initially A is working alone, and what did he do? A worked alone for 5 days. So from here to here, this is 5 days period, A has worked alone. Now what happened after 5 days? Well, A left. Now who's working on this project? B alone is working. Now what happened here? Remaining part of the project was completed by B in 20 days. So B here was the person who worked for 20 days. So just above the line, I am writing the number of days here worked by individuals. Just below the line, I am writing their names. So simple as that. 5-day work of A. Now A completes the work in 15 days. He can complete the work in 15 days. So his 1 day work will be 1 by 15. 2 days will be 2 by 15. 3 days will be 3 by 15. So 5 days will be 5 by 15. So A works for 5 days. Alright, so hence his 5-day work will be 5 by 15. Plus, now look here, B works for 20 days. But what is the working efficiency of B? I mean, in how many days can B alone complete this project? It is not given. For A, it is given. A can complete this project working alone in 15 days. But B, how much time does B take? Well, that is exactly what we have to find out here. So, 20 days work of B. I'll just keep it like this. And together, they complete one work. So that's how it is. So now this 5 and 15, they get cancelled. So it is 1 by 3. Now this 1 by 3, we will take to the other side. So that we get 20 by B is equal to 1 minus 1 by 3. So hence we get a 20 by B is equal to 2 by 3. Now, you can always cancel these two. Here we get a 10. B goes here, 3 comes here. So finally we get B is equal to 10 into 3. So B alone can complete this project in 30 days. So this is one way. There is another way in which we can solve this. See, as it is, you see that A here completed 1/3 of the work. Now, how much part of the project is remaining? 2/3. Who's going to complete this 2/3? B is going to complete this 2/3. And B is completing this 2/3 in 20 days. So simple, no? 2/3, 20 days. So 3/3, 3/3 is what? One full work in 30 days. 1/3 would have been 10 days. So simple proportion I'm taking here. Alright? So still we get 30 days as a duration in which we alone can complete this project. A computer software can be developed by P in 20 days. And the same software can be developed by Q in 25 days. Q worked alone for 10 days on the software and then stopped working. Okay, so we need a timeline here. Alright. Now here, Q alone worked for 10 days and then stopped. So after 10 days, Q is not working anymore. Now in how many more days will P complete the remaining work required to develop the software? How many more days? We don't know. So in mathematics, whatever is unknown, that is always taken as X. So who worked for these X days after Q stopped working? It was P. That's it. So if you know how to frame this timeline, you will understand the logic behind the question. So 10 days work of Q. See, Q can complete the work in 25 days. So 1 day work of Q, 1 by 25. 2 day work of Q, 2 by 25. So 10 days work of Q, 10 by 25. So in 10 days, Q completed 10 by 25th of the work. Plus X days work of P. P can complete the work in 20 days. So in X days, P will complete X by 20 days. Together, they complete one work. That's it. Now this 10 and 25, will get cancelled. Alright. So 5 2s are 10, 5 5s are 25. Now this 2 by 5 will go here. Anyhow, 2 by 5 of the work has been completed by P. So remaining is how much? 3 by 5. So X by 20 is equal to 1 minus 2 by 5. That is nothing but X by 20 is equal to 3 by 5. Now this 5 and 20 will cancel here itself. So we know 5 4s are 20. Now this 4 will go here. So X becomes 3 into 4. That is 12 days. And the question asked is, in how many more days will P complete the remaining work? So P here will take 12 more days to complete this remaining work. Now look at this question. A task can be completed by X alone and Y alone in 10 days and 20 days respectively. Now they started working together on the task, but X stops working after 5 days. Now what is the story here? Timeline says that initially X and Y, they started working together, but after 5 days, X stops working. Now how many days will Y take to complete the remaining work? We don't know. We have to find that. So X days, the small X days, or because X is already given here, so let us not take X here. Let us take n number of days for Y. So let us convert this into equation. So 5 days work of X and Y. Oh, let us find out what is the combined efficiency of X and Y. For that we use LCM method. X can complete a work in 10 days. Y can complete the same work in 20 days. LCM is 20. This is 2. This goes by 1. This is 3. 20 divided by 3. So this is what we get. Let us not convert it into mixed fraction 6 2 by 3. Not required, because we need to perform some calculations here. So what we get here is 5 days work of X and Y combined. So 5 by 20 by 3 plus n days work of Y. Y can complete this work working alone in 20 days. So together they complete one work. Obviously this 3 here goes up, like this. So we get a 5 into 3 by 20 plus n by 20 is equal to 1. Now let it be. You can always cancel 5 and 20 here. Alright, this will become 3 by 4. But then you would be doing two calculations. It will become 3 by 4. 5 and 20 gets cancelled. And then you will have to balance 4 and 20 on the other side. So there would be two calculations. Whenever you find that the denominators have the same value, in that case, kindly make sure that you do not do any cutting. Why? Because anyhow, this complete figure will be going to the right hand side, and this 20 is going to cancel this 20. So your answer will be there in front of you. How? Let's have a look. So n by 20 is 1 minus this 5 into 3 is 15. So 15 by 20. So n by 20 is nothing but it is 5 by 20. Now you can see this 20 cancels. So this implies that n is nothing but it is 5 days. So y takes how many days? How many days will y take to complete the remaining task? Well, y will take 5 days to complete the remaining task. So I hope that this becomes much more easier and faster and much more logical in your approach. And this would tend to reduce any chance of committing an error also. Now, each of A, B and C can complete a work in 10, 15 and 12 days. Now the three start working together. All right, now let's view the story. Three start working together. A, B and C, they are working together. But A leaves one day after the work starts. So let us say this is one day has gone. What happens? A has left the work. Find out the total time. Please always keep the question in your mind. Find out the total time in which the work gets completed. Now, after one day, A has stopped working. After this one day, it is obviously B and C who's working. For how many days? We don't know. So let us say X days. Now let us try and find out the LCM of A, B and C. A, 10 days, B, 15, C, 12. 15 being the highest. The moment you see 10, 15 and 12, the number that should strike to your mind is 60. Get used to it. Yes. So 10 into 6, 15 into 4, 12 into 5. So 6 plus 4 plus 5, that is 15. So 60 divided by 15, that is 4. So if A, B and C were working together on the entire project, they would have taken only 4 days to complete it. But A left after one day. So we would also require for B and C, we would require in how many days can B and C complete the work, because we need their efficiency as well. So let's take it here. 15 and 12. Once again, the LCM is 60. So this is into 4. This is into 5. This is 9. So 60 divided by 9, which is nothing but 20 by 3. Alright, so this is something we will keep in our mind. Now let us see one day work of A, B and C, which is 4, is 1 by 4. Working efficiency of ABC is 4 days. They can complete the work. So in one day they will complete 1/4. 2 days, 2/4. That is half. 3 days, 3 by 4. 4 days, 4 by 4. That is complete one work. Alright. So 1 by 4 plus X days work of B and C. Now this is B and C can complete the work in 20 by 3 days. So this shall become 20 here. By 3, 3 goes up. Alright, we will take the reciprocal. So it is 3x by 20. Together they complete one work. So 1/4 work is completed. 3/4 remains. So we know directly you can now start reducing the steps. There is no need for us to write 1 minus 1 by 4. You know that it is 3 by 4. So now you can do the cuttings. This 3 and 3 will cut. 4 and 20 will cancel. And it is 4 5s are 20. So this is what? X by 5. So x by 5 is equal to 1, which means x is equal to 5. Read the question carefully. You should always know what the question demands. Trust me, this 5 will be given to you in one of the choices, for sure. because it is not the answer. Because the question here is find out the total time. See now, total time here is this x and 1. Alright, so it is 1 plus x. So this becomes 1 plus 5. Total time is 6 days. Alright, so that should be your answer here. Okay, look at this question. Jack can complete a project in 20 days and Jill can complete the same project in 30 days. Jack and Jill, remember? You should. Both together start working on the project. Alright, now the story starts. Let's begin the story. Both Jack and Jill have started working on the project. But Jack stops working just 5 days before the project's completion. This is where project gets completed. 5 days before is here. What's happening? This is where Jack stops. So who has worked during these 5 days? Obviously, Jill has worked. So you have Jack and Jill working for this entire duration. But how much is this duration for which Jack and Jill worked? Don't know. So whatever we don't know, we have X in that place. Alright? Now what is the question? Find out the number of days taken to complete the entire project. So what do you want? You want the total time taken to complete the project. Alright, so let's start solving this. For that, let's take LCM, Jack, Jill, 20, 30, LCM 60 into 3 into 2, 5 units. So 60 divided by 5, that is 12 days. So Jack and Jill together could have completed the entire project in just 12 days. But Jack and Jill, they work together only for X days. So X days work of Jack and Jill is X by 12 plus 5 days work of Jill. Jill can complete the project in 30 days. So 5-day work is 5 by 30. This is 1. This cancels. So we get 1 by 6. So now you know X by 12 is equal to 1 by 6. You will take here. So 1 minus 1 by 6 will become 5 by 6. Becomes 2. 6 2s are 12. 2 will go here. On the other side, so X is equal to 5 into 2. That is nothing but 10 days. But this is not the answer. And trust me, 10 days would definitely be mentioned among the choices, so that you mark your answer incorrectly. So read the question carefully. Read the question carefully. You should know what does the question want. These are not silly mistakes. There is a process, method to perfection. We miss those steps, and that is where we do not become perfect. And then we say, oh, I committed this error. No, you need not. By just installing a simple process that whenever you are going to mark your answer, before that, you are going to read the question statement carefully. So what does he want? Find out the number of days taken to complete the entire project. Entire project is always total time. So total time is how much? Well, total time is 5 days here plus X days here. So it is 5 plus X. That is 5 plus, this is what X is? That is 10. So total time taken here should be 15 days. That is your correct answer. Now in this question, A can complete an assignment in 15 days. B can complete the same assignment in 20 days, whereas C can complete it in just 12 days. If all the three start working together and A stops working 3 days before the completion of the assignment, alright, so this is how the story goes. All A, B, C, they start working together and A has stopped working just 3 days before the completion of the assignment. Find out the total time, fix it in your mind, alright, register it properly, taken to complete the assignment. Now initially A, B and C, they worked for how many days? Well, simple, we don't know, so X days. Now for A, B and C, let us take the LCM. It is 15, it is 20, it is 12, and we have 60 here, because it is 4, it is 3, and this is 5. So hence, 12. So 60 divided by 12 is nothing but 5 days. So X days work of A, B and C will be X by 5 plus 3 days work of B and C. Because A is not working. For 3 days B and C have worked. So B and C here 20 and 12. Once again, LCM is 60 into 3 into 5. So it becomes 8. So 60 divided by 8 is, see both the figures they go by 4, right? So 4 into 15 is 60 and 4 twos are. So 15 by 2. So 3 days work of B and C. So it is 3 by 15 by 2. So it is 3 into 2 by 15. That's what we have. Together they complete a work. So cutting happens here. 3 5s are. So 2 by 5. So X by 5. 2 by 5 goes here, becomes 3 by 5. 5 5 cancels. X is equal to 3. Then total time is asked. So total time is this 3 plus this X. Immediately you should go to this timeline. So it is X plus 3, which is 3 plus 3, that is 6 days. Now, let's look at one more variety here. A, B and C can complete a work in 10, 15 and 12 days. 10, 15, 12, LCM 60. If all the three start working together, okay, now this is how the story goes. But A leaves after 2 days of the beginning of the work. This is given to us that for initial 2 days, A, B and C, all the three persons worked. And then A left after 2 days. And also B leaves 1 day before the completion of the work. So 1 day before the completion of the work, B leaves. In between, who works? See, after A is gone, in this particular duration, B and C are working. Then B leaves, then last 1 day, C alone is working. So this is the story for us. So 2 LCMs we have to find out. LCM for ABC and then BC. LCM might be the same. Their working efficiency needs to be found out. So let's do it here. ABC, 10, 15, 12. This is 60 into 6 into 4 into 5. 15. 60 divided by 15 is 4. B and C, 15 and 12. Again, the LCM is 60. 15 into 4. 12 into 5. 4 and 5 is 9. 60 divided by 9 is 20 by 3. 3 into 20 is 60. 3 into 3 is 9. Now let us do it. Now 2 days work of A, B and C is 2 by 4. Because A, B, C can complete the work in 4 days. 1 day work is 1 by 4. 2 days work is 2 by 4, which is half. Plus X days work of B and C. That is X by 20 by 3. So we have the reciprocal 3x by 20. Plus 1 day work of C. 1 day work of C. C can complete the work in 12 days. So in 1 day, C does 1 by 12 of the work. So together they complete 1 work. Now let us do one thing here. You know, this is half. Half you will add to 1 by 12. Again, you will take LCM between 12 and 2. So better you do it here itself. So 4 into 3 is 12. 2 into 3 we will get here. Okay. So we have 6 by 12 plus 1 by 12 plus 3x by 20 is equal to 1. Now 6 plus 1 is 7. 7 by 12. Take it on the other side. So you have 3x by 20 is equal to 5 by 12. 1 minus 7 by 12. Right? That is 5 by 12. Now you can do the cancellation here. These cancel. This is 4 into 3. This is 4 into 5. So this means x here is 5 by 3 into 5 by 3. That is 25 by 9. How much is this 25 by 9? Well, so 9 twos are 18. Left over is 7. So 7 by 9 days. Now what is this? This is the value of x, mind you. Now he says, in how much time will the work get completed? That is, he's asking you for total time. So total time here is nothing but it is 2 days plus x days plus 1 day. So that is 2 plus x, that is 27 by 9, plus 1, that is nothing but 5, 7 by 9 days. So I hope this is clear to you, and this is going to be the fastest method and the most logical method by which, without committing an error, you are able to solve the questions. While I'm explaining the question to you, I will have to write down these steps. But obviously, when you are doing rough work, you can always skip steps, working out certain steps in your mind, certain calculations here like 6 by 12 and 1 by 12. I need not write. This should happen in your mind. So 7 by 12, you should be subtracting from 1. So directly from here, you should be jumping to this step. Looking at this step itself should give you 25 by 9, all right, and 27 by 9, and then you can always find out the number of days. So obviously, it would take near about 20 seconds to read the question, another 30 to 40 seconds to solve the question, because on an average, you are going to get around 1 to 1.5 minutes easily for solving question in mathematics on an average. Now, A and B together charge rupees 60,000 to complete a job. Now, it is known that A alone can complete the job in 6 days. Okay, so A alone can complete the job in 6 days. B alone can complete it in 8 days. However, with the help of C, the job gets completed in just 3 days. How much amount of work has C done? Let us first of all find out how much amount of work is done by A and B combined together. So 6 and 8, the LCM is 24. 6 4s are 24, 8 3s are 24, that is 7. So dividing 24 by 7, well, 24 by 7, we all should be, isn't it so? That is nothing but 7 3s are 21, remainder 3, 3 by 7 days. If A and B are asked to complete the job, they would have completed this in 3 by 7 days. But the job is getting completed in 3 days with the help of C. Now here we can very clearly see that A and B, their 1 day work is 7 by 24. Now A and B, their 2 day work is 14 by 24. A and B, their 3 day work is 21 by 24. And the work got completed in 3 days. So A and B, their contribution has been 21 by 24. Now that means C's 3 days contribution is 3 by 24. That means C's 1 day contribution is 1 by 24. Which means that C alone can complete this work in 24 days. Also, if you see A, B and C, 6, 8 and 24, and your LCM is 24, this is into 4, into 3, into 1, 4 plus 3 plus 1 is 8, 24 divided by 8 is 3. So anyhow, how much money will each person get? Now here itself, you know that A has done 4 units of work, B has done 3 units of work, whereas C has done only 1 unit of work. So A is to B is to C, 4 is to 3 is to 1 is what we have here. In total, these are 8 ratio points as we learned in ratio proportion. And the total amount here is 60,000. So this is 4x, 3x, 1x, 8x, because 4 is to 3 is to 1 is just a ratio, whereas 4x, 3x and 1x with x as the common multiplier will be the actual numbers. So 8x is equal to 60,000. We know now x is equal to 7,500 when you divide 60,000 by 8. So everywhere you multiply with 7,500. So C here will get 7,500. B will get 22,500 and A will get 30,000. Makes sense? 30,000 for doing 4 units of work, 22,500 for doing 3 units of work makes it 52,500, and 7,500 for doing just 1 unit of work. So Any one of these can be asked to you, or maybe all the three could be given to you amongst the choices. But here we are emphasizing on registering the concept in your mind. The moment you get your answer, you just have to look at the appropriate choice, mark, and earn your marks. Now look at this one. This is another variety in time and work. Now a work can be completed by 45 men in 16 days. Alright, so I'm starting the story here. This is how the story goes. 45 men can complete a work in 16 days. After they work for 6 days, stop. So let us say after 6 days, what is their position? Well, 45 men will be left with 10 days of work. Is it or not? 45 men can complete a work in 16 days. They started working, and after 6 days, what will be their position? They will be left with only 10 days of work. But what is given in the question? What happened after 6 days? 30 more men joined them. So now 30 more men have joined. The number of men has increased from 45 to 75. Then find out in how many days will the remaining work get completed. See, after 6 days, these 45 men were supposed to complete the remaining work in 10 days. But now the number of men is 75. Simply, you can use unitary method. 45 men can complete a work in 10 days. So 75 men can complete the same work in how many days? More days or less days? Less days. So out of the figures on the left side, less by more is what we will take. So this becomes 45 by 75 into 10. So 15 threes are, 15 fives are, 5 twos are. So we are left with only 3 and 2. So 3 into 2, 6 days. So now the remaining work, which was to be completed by 45 men in 10 days, now because 30 more men have joined, the total number of men has become 75. So now the remaining work will get completed in 6 days. Okay, look at this one. 2 men and 3 boys can complete a job work in 10 days. Okay, so 2 men and 3 boys, 1 day work is nothing but it is 1 by 10, because together they can complete the job in 10 days. So in 1 day they will complete 1 by 10 portion of the job. Whereas 3 men and 2 boys can complete the same job in 8 days. Okay, so 3 men and 2 boys can complete this job in 8 days. So their 1 day work will be 1 by 8. You can solve it as simultaneous equations. There is no issue at all. So what we will do is, we have to find out the time required by 2 men and 1 boy. So let's do cross multiplication here. Let us multiply this complete equation with this 3, and let us multiply this complete equation with this 2. Now what do we get? We get 6 men. Let's say plus 3 into 2 is 6. So 3 into 3 is 9. And this is going to be 3 into 1 by 10, which is 3 by 10. Now similarly here, 2 into 3, 6. 2 into 2, 4. And then 2 by 8, which is 1 by 4. So let us reduce these. So the 6 men cancels. 9 minus 4 is 5. So 5 boys is equal to 3 by 10 minus 1 by 4. Which means the LCM here is 20. So this is 6 minus 5. It is 1 by 20. So 5 boys can complete 1 by 20 of the work in 1 day. So 1 boy can complete 1 by 20 into 5, that is 1 by 100 of the work. Now let us substitute this value of boy in any of these equations. So let us substitute it here in this first equation. So 2 men plus or and 3 boys work of 1 day. 1 boy's work of 1 day is 1 by 100. So 3 boys work of 1 day is going to be 3 by 100. Now this is equal to 1 by 10. So 2 men is equal to 1 by 10 minus 3 by 100. Well, let's improvise here. Let this be 10 by 100. So it becomes 7 by 100. So 2 men you found out here. 7 by 100. 1 by you already have here. 1 boy capacity is 1 by 100. So 2 men and 1 boy will be able to complete this work. For 2 men, 7 by 100. For 1 boy, 1 by 100. So 8 by 100. That is 2 by 25. Now this is 2 men and 1 boy's 1 day work. So therefore we can say that 2 men and 1 boy can complete this work. Well, take reciprocal of this as we usually do. In 25 by 2 days, and that is nothing but 12 and a half days. That's what we have with us. Alright, you have another variety of question. This being the last one. If 12 men can complete a work in 10 days, working 6 hours per day, then in how many days can 10 men complete double the work working 8 hours per day? So here we will make use of formula M1 H1 D1 by W1 is equal to M2 H2 D2 by W2, where M pertains to number of men, H pertains to number of hours that a person works per day, D pertains to number of days, and W work. So let's take it. If 12 men can complete a work, so one work, we have done this, in 10 days, working 6 hours per day, so into 6 into 10 is equal to, the work is same, right? Then in how many days, so D is required to be found out, can 10 men, so 10 into double the work, so 2 is to be written in the denominator because the work has been doubled, working 8 hours per day. So 10 into 8 into D2. This is what you are supposed to find out. D2 or D, any one of these you can take. Now let's do the balancing act here. 10, 10 cancels. 2 and 8 cancels, goes by 4, and 4 and 12 cancel by 3. So 3 into 6 is what remains. So the number of days here which are required is 6 into 3, that is nothing but 18 days. Alright, so these were certain questions, types, patterns, difficulty levels that have appeared in previous year papers or that would formulate the clarity required for the basis, basics, concepts and fundamentals, including approach towards solving the questions. Mind you, we also have to save time. Please do remember that as little as you write, the faster you will be. More you write, more rough work you do, written rough work, more time will be consumed. So start working here because the speed of your thought is much more than the speed at which your hand writes. So with that, we will meet again in another session. Till then, I wish you all the best. Stay safe. Thank you so much.